For lesson 10.2, we're going to be talking about independent and dependent events. We should know what independent and dependent are back from Algebra 1. Today we're going to be talking about how these events can affect probability of things. Okay, so first, on that top line for your definition of independent events, we've got that it is the outcome from one action does not affect the probability of the outcome of a subsequent activity. So, what that means is whatever happens in the first activity that they're asking you to do, whether that's drawing something from a bag or rolling a dice, whatever you do the first time won't affect what you're doing the second time if it's an independent event. Okay? So, there's also a place for you to list the 3 signs that could let you know that you are looking at an independent event. So the first one of those would be that the 2 events are unrelated. So maybe the first thing is drawing a card from a deck of cards, while the second thing is rolling a dice, right? Those have nothing to do with each other, so it doesn't matter if I take a card from this stack, that won't affect me rolling a dice, right? Okay? The second that could indicate that you're looking at an independent event would be that you repeat the exact same event with an item whose numbers don't change. So maybe they say, what's the likelihood of you rolling a dice 2 times in a row and getting a 6 both times? Well, I can roll the dice once, and then I can roll it again, and I have the same chance, right, of getting a 6 both of those times. Okay? It's not like if I reached into a bag and took out a ball, and then you ask what's the probability of you getting another red ball, right? Well, there's one less in the bag if I already took one out, right? So this is saying with an item whose numbers don't change, like if you spin something or roll a dice. The third indicator would be if you do draw something out of a stack or out of a bag, you replace it before you do it the second time, so that there's still the same number of items in the pile that you're pulling something from. Okay. So for independent, there can't be anything from the first event that will affect what you're doing for the second event. Does that make sense? Okay. All right, and then here at the bottom it says the probability of 2 independent events, A and B, is equal to the probability of event A times the probability of event B. And if you see right there below where you wrote your 3 indicators, there is a place for the formula of independent events, and that's what we're going to put right in those blanks. Yes. So what this says is the probability of event A and event B is equal to the probability of event A times the probability of event B. And again, this is what we're writing where it says independent formula. Right there. So P parenthesis A comma B is equal to PA times PB. All this goes on line 1, and then there's an equal sign. This goes on line 2. That goes on line 3. What goes before the equal sign? Okay. Does everybody have that formula written from the bottom there? That's the most important part, because that's what we'll need when we look at the next example. Okay? Okay. So, keeping this formula in mind, we're going to look at the first example here. It says, suppose you spin each one of these 2 spinners. What is the probability of spinning an even number on the first spinner and a vowel on the second spinner? Okay, so first we're just looking at the probability of spinning an even on the first spinner. Okay, well, how many places are there total for me to land on? 6. And how many of those are even numbers? 3. So the probability of hitting an even is 3 out of 6. And just like with our ratios, we want to simplify when we can. So we'll just simplify. So this simplifies to 1/2 because there were 3 evens out of 6 possible outcomes. All right, now we're going to do the same thing for our vowels. So on the spinner with the letters, how many possible outcomes are there? 5. And how many of those are vowels? 1. So the probability of hitting a vowel is 1 out of 5. And according to our formula, if this is event A and this is event B, what are we supposed to do with them? Multiply them. So I would have 1/2 times 1/5, which would tell me the probability of us first hitting an even and then hitting a vowel is 1 out of 10. All right, so this is an example of an independent event because me spinning an even number here had no effect on me landing on a vowel over here. They were 2 separate events. All right? Okay, guys, stop talking, please. All right, then we have our dependent event. So here's your definition for dependent events. So unlike our first, the outcome from one action is going to affect the outcome of any subsequent action. So in this case, whatever you do for your first event, is going to affect what happens when you do your second event. Okay, and there's a couple of indicators for these as well. But in other words, the result of the second event is going to change because of what happened in the first event. So these are not going to be 2 separate things happening. It might be that you there's a ball and it has red and blue, a bag that has red and blue balls. You take a red one out and they ask, what's the likelihood of you getting a red ball out of the bag? Well, you already took one out, so the probability is going to change. Okay. So the probability of 2 dependent events, A and B, is equal to the probability of event A times the probability of event B, so similar to last time. However, the probability of event B is now going to depend on what happens in A. So our formula for a dependent will change slightly. So our new formula is still going to give us the probability of event A happening and then event B. But although we still keep probability of event A happening as normal, I'm going to have to multiply it by what happens in B after A is already happened. So keep in mind that there's usually going to be less for you to choose from come time for event B. All right. All right. So here is our example of a dependent event. It says there are 6 black pens and 8 blue pens in a jar. If you take a pen without looking and then take another pen without replacing the first, what is the probability that you will get 2 black pens? Okay, so first, my first drawing, all the pens are in there. How many pens are there total? 14. And what's the likelihood of me getting a black one on the first try? Right. And just like last time, we want to simplify that. But now, on my second pick, there are how many pins in there since I didn't put the one I already drew back? 13. And how many of those are black if I drew a black on the first time? 5. So the likelihood of me drawing a black the second time is going to be 5 out of 13. Now, just like in the previous formula, they said that we should do what with these 2 events? Multiply them together. So I would have 3 over 7 times 5 over 13, which is a probability of 15 over 91. So your chances go down because you already drew one of them out of your stuff. So next, here are 4 scenarios. You do not need to write these scenarios down. I want you to read each one of them and write on the blank 1, 2, 3, and 4 whether you think one of those is independent or dependent. So just write on the line if it's independent or dependent. I'll give you a second to read them. Okay. So do we think that event 1 is independent or dependent? Dependent. Good. All right, what about event 2? Independent. Event 3? And event 4. Very good. All right, so we've got another example here. It says, what's the probability of you picking a jack first and then a factor of 12? Okay, so out of these cards, how many cards are there here? 5. And how many of them are a jack? So the probability of picking a jack is 1 out of 5. And then I'm looking at the spinner for factors of 12, so numbers that multiply to give me 12. Can I multiply 1 by something to get 12? Okay, what about 2? 3, 4, 5, 6, 7, or 8. Okay, so how many of those did we say yes to? So we got 5 out of 8. So I multiply these two together, and the probability of picking a jack first and then a factor of 12 is 5 over 40. And I forgot to ask this first, but obviously this is an independent event because these were 2 separate things happening. One doesn't affect the other. Okay? All right, oh, and 5 over 40 will simplify to 1. All right. Okay, next one. Rolling a 6 and then not rolling a 5. Independent or dependent? Independent. Because if I roll a dice, I can roll it again. Nothing's going to change. Okay? All right. Oops, sorry. So the probability of rolling a 6 is 1 out of 6 because it has 6 sides, right? What's the probability of not getting a 5? 5 out of 6 because it could be anything else. So our likelihood of getting 6, then not a 5, would be 5 out of 36. Good. All right, and then our last one here, picking Q and picking Q again, but do not replace the letter. Independent or dependent? Dependent. Good. All right, so how many letters are there in the alphabet? 26. And how many Q's are there in the alphabet? 1. So 1 out of 26. Okay, it says we took out the Q and we didn't replace it. So now how many are there in the bag? 25. And how many Q's are in the bag? 0. So 0 out of 25 chance. So 1 times 0 is, and 26 times 25 is 650. But 0 over 650 is just 0. So the likelihood of you being able to draw Q and then Q again, not possible. There's only one Q in it. All right.